good afternoon, good evening, wherever you are in the world. I hope you're doing well. My name is Chris, and this morning I'll be doing a video on the configuration of NAT overload, also known as PAT. Shout out to Nefx Meg. I hope I'm pronouncing that correctly. They left a comment on one of my videos requesting I do a video on the configuration of NAT overload. So this one's for you. Shout out to you. I hope you're doing well, and good luck. This is going to be a very simplified explanation of how this technology works. The focus here is on the configuration. So if you're in that network plus, security plus, kind of getting into the CCNA, I think this is a good place to start. However, if you want that deep dive into how the tech works, I would, shoot me a comment, send me an email, and I'll do a video on that at some other point. But right now, we're just covering a brief explanation of the technology, and then we're focusing on the configuration. So, okay, so NAT overload, also known as PAT. NAT stands for Network Address Translation Overload, and then PAT stands for Port Address Translation. They mean the exact same thing, guys. They mean exactly the same. So you could say PAT, you could say NAT overload. You're not wrong. They're interchangeable. I prefer saying NAT overload simply because NAT and overload are both in the configuration for the router. So it just makes more sense from an educational standpoint to say NAT overload. It's less confusing. It just makes sense. So from here on out, I'm going to say NAT overload, or I'll just say overload. Just know when I say NAT overload or when I just say overload, it means PAT, guys. It's the same thing. So, what are you doing, Pumpkin? Sorry, guys. My daughter. This is like prime time for my daughter, so she's just waking up. But anyway, so what is it? What is NAT overload? It is. It allows multiple devices on a local area network to share the same exact public IP address. So you'll have PC Neo here and PC Morpheus, and they have private IP addresses, right? Because they're on a private network, they're on a local area network. So these two devices, let's say they want to communicate with the server over here across the wide area network on a public network. The server, the Oracle. So PC Neo and PC Morpheus send their packets to router Trinity, and router Trinity that has NAT overload configured on it will then assign PC Neo and PC Morpheus the same exact public IP address, which is this public IP address right here. This public IP address belongs to the outbound interface on router Trinity. This interface is facing the wide area network, so it's a public IP address, right? So PC Neo and PC Morpheus will both be assigned this public IP address. If we configure it correctly, they'll be assigned this public IP address, and then they will be each given their own unique port number. So that is what NAT overload does, or PAT. That's what it does. Very, very simplified. It makes it so multiple devices can share the same public IP address, right? This IP address right here of the outbound interface. They can all share that same public IP address. They are overloading, right? They are overloading that public IP address, that one interface, with that assignment to multiple devices with a different port number, port address translation. So if you ever get lost and you're like, man, I forgot what NAT overload means in PAT, I don't remember the technology, right? NAT, network address translation, the network addresses are being translated. Overload, the outbound interface of the router, right? The public IP address is being assigned multiple devices, right? The same IP address, the same public IP address is getting assigned to multiple devices on the local area network, and it's being overloaded. Port address translation. The port is unique for each device. Same IP address, same public IP address for each device, different port numbers. That's it, guys. That's it. You can take a deep dive into this, but we're just covering the basics right now just so you get familiar with it. So that's NAT overload, aka PAT. Benefits of it, it increases your network security. So by masking your network, essentially when traffic is leaving your network, it looks like all of your traffic is assigned the same public IP address, which it is. So it makes it harder for attackers to counter or corner your devices, to gain information, to just get a layout of your network. It's very hard for them to do when every single device is being assigned the same public IP address versus PC Neo being assigned its own unique public IP address and PC Morpheus being assigned its own unique IP address or public IP address. So it masks your network, and then it reduces IP address exhaustion. So imagine if on this network we had 50 devices, 50 PCs, and each one had their own private IP address and their own public IP address, right? Their own unique public IP addresses. this would reduce. I mean, we would lose all of our IP addresses like instantly, right? So, what NAT overload does is it allows all 50 of those devices to share one public IP address, and therefore it reduces IP address exhaustion. It's also easier to manage that way too. Um, Instead of saying, oh yeah, PC Neo gets this public IP address and PC Morpheus gets this public IP address, and instead of having one-to-one, you have everybody using the same public IP address. So reduces IP address exhaustion. So let's get into the configuration. Oh, that's the switch. Just so you know, guys, this network is all configured already, so I'm not going to do it in front of you. The only thing is, like you can see here, all my interfaces are labeled and configured, and they have all the subnet masks on there as well. The only thing you don't see on here is the gateway of last resort. So make sure you do not miss setting up your default gateway, and make sure you do not miss setting up your gateway of last resort. Make sure you do not miss that when you're configuring these networks, or else you will run into problems. If you have any questions, feel free to ask. I'll help you out. But make sure you don't miss that. And then you could, of course, you could just follow my my layout as well. So, okay, so let's configure router Trinity real quick. So we'll go enable conft and we'll go into the interface gigabit 0/0/0. And this is our inside interface, right, guys? So this interface right here, gigabit 0/0/0 on router Trinity, is facing the inside. These are our local area this is our local area network with our private addresses, our devices that have private IP addresses, right? This is inside, and we are going to translate to the outside, right? So this is the inside interface. This is the outside interface. All right, outside is public, inside is private. Okay, so interface gigabit 0/0/0, IP NAT inside. See that word NAT? It just makes sense to refer to it as NAT overload because you're using the words in your configuration. Okay, so IP NAT inside for gigabit 0/0/0. Like I said, this is our inside interface. We are translating it to the outside interface, that public facing interface, a wide area network facing interface, right? So we can go into our other interface serial 0/1/1/0, and we'll do the same thing. IP NAT outside, right? This is our outside interface. This is the interface with this IP address. This public IP address is going to be assigned to all of our devices that want to send traffic over the wide area network. PC Morpheus is going to get assigned this public IP address. PC Neo is going to be assigned this public IP address from this interface here because it is the outside facing interface, okay? So IPNet outside. Let's do a no shutdown. Actually, I don't think we have to do that. Okay, so exit, and let's do this. Let's go, let's make our access control list. So we're going to go access list, and we're going to do a question mark, and we're going to name it access list 1. So if you don't know what an access control list is, please go watch my other videos on it. I did extended lists and standard lists in depth. So it's essentially just setting rules on your router saying what traffic is allowed and what traffic is denied. What we're doing here is we're creating an access list named access list number 1, and that access list is going to permit traffic from the network 192.168.1.0. This is our subnet, guys. 192.168.1.0 is our subnet. 192.168.1, right? That's our subnet right there. We're permitting all traffic from this network, from this subnet. We're permitting all traffic through router Trinity, right? So 192.168.1.0, and we will go with oh yeah, the wildcard mask 0.0.0.255. Okay, so this is our wildcard mask. So we have our access control list named number 1. We are permitting all traffic from 192.168.1.0 with our wildcard mask. Okay, all right, it's permitted. Good, very good. So our last command, IP NAT inside. We are translating our inside IP addresses, right? These private IP addresses, we are translating the inside source list. This is our access control list that is allowing the traffic through router Trinity. So IPNAT inside, our inside addresses, source list number 1, that's our access control list number 1, and we're assigning the interface, right? So our inside interfaces, our inside devices here, like before our inside, our NAT inside, the IP NAT inside interface right here, all these devices here, when they pass through this interface, they are going to be translated, right, to this public IP address on this interface here, this public IP address. That's what we're saying right here, guys. We're saying the inside devices, right, these inside in the region of the inside, right, we're allowing them through router Trinity through access control list 1, right, and we are going to translate them to the interface of serial 0/1/0. All right, so they will receive the public IP address of serial 010, right? This one right here, this IP address, this public IP address right here. All right, so, and the next commit, the last thing to add is overload. Overload means this IP address, this interface, right, serial 010, the IP address assigned that interface is going to be overloaded. It's going to be shared amongst multiple devices on this local area network when they are trying to communicate off of that local area network, okay? So IPNet inside source list 1, interface serial 0/1/0, overload, and we're going to hit enter and exit and exit. Okay, so how do we check our work? I'm going to show you right now. So go to PC Neo, and we're going to ping the server 10, or let's do this. Let's do a continuous ping. All right, so we're pinging. We're going to do a continuous ping from PC Neo to the Oracle. Okay, let's do that. And while we're waiting for that to kick off, we're going to go to PC Morpheus, and we're going to do the same thing. Open up the command prompt, ping -T for the continuous ping 0.0.5, which is our Oracle server. All right, so let's get both of them running here. Let's check this out. All right, so we've got PC Neo, successful pings, and PC Morpheus also successful pings, right? So this looks good, right? No issues here. So how do we prove that our IP addresses are being translated appropriately? So we go into router Trinity, right, and we do enable, and we're going to do a show IP NAT translations. All right, so lots of stuff going on here. As you can see, all right, show IP NAT translations. We have our right here. We could see this is .10. This is our Morpheus, right? Morpheus, our .10, our inside local, right? Look familiar? Is being translated to this right here, right? This is the same IP address, right? Take a close look. It's the same IP address as the outside facing interface, right? You remember assigning that? You remember configuring that? Every single one of our devices is going to be translated to this IP address on its way out. It is being overloaded. This interface IP address is being overloaded, right? So you can see here it says more. If we scroll down, you'll see, look at this. Look what we have here. This is PC Neo. So we saw PC Morpheus, and PC Morpheus had the same IP address as PC Neo. Look at PC Neo. Same exact thing. PC Neo .20 is now being translated to the same outside interface IP, the public IP address, as PC Morpheus, the same exact one. They are overloading that public IP address, that outside interface, okay? This is proof that our IP addresses, our private IP addresses, are being translated, and that interface is being overloaded. That IP address, that public IP address, is being overloaded. So that is how it works.